Happy New Year, Honors Pre-Calculus students, and welcome back, everybody. Today, I'm going to teach you in this video how to solve exponential and logarithmic equations. We are still in Unit 2, but it is a topic 2, which is solving exponential and log equations with and without calculator. Homework assignment for this is posted in the module. Check the homework. Before you submit the homework, you can come. I encourage you to come for Wednesday's check-in. So let's take a look at these notes. These notes are posted in the module. Notes are posted in the module. Check the module for these notes. So I would like you to pause for a minute here, and this is a matching properties of log. So feel free to go ahead, do the matching of properties. We are still going to use the properties of log. For example, this one would be, we move the 2 here and we move 3 here. So this is ln x square y cube, which you can check the answer here. I'm going to bring my answers here in case if you want to check that. So you may want to pause this video and do all this as a warm-up. So these are the answers: F, E, D, G, B, A, H, and C. To solve the equations, we are still using these properties of log. So let's take a quick review about these properties of log in case you forgot about this during the holidays. So log plus log is a product. Log minus log is a division. This is the power rule. This power exponent comes as a coefficient. Change of base is the very important one. Log x over log b with any base. And additionally, we have this new one here is, we call it a 1-to-1. If b to the x equal to b to the y, then we can say x equal to y. We can drop the base. Same thing with the log. If they have a same log with a base, we can say x is equal to y. So these are 1-to-1 properties, which are very obvious one. Of course, this is all the time. You have to know this, how to change log to exponential, exponential to log. So let's take a look at a couple of examples here in this packet, in these notes. And one more time, you have these 1-to-1 properties. So let's take a look at here the examples. So 3 to the x equal to 81. You must rewrite them as 81 is 3 to the 4th. We are not changing to log here. We are trying to get the same base. So 3 to the x is equal to 3 to the 4th. They both have a same base, so we can say x is equal to 4. Same thing with the log. Log of x to the base 2 minus log of 5. You can add log 5 on the other side. They both have a same base. With log, we can say x equal to 5. So we are going to use these properties to solve for the equations. So first of all, let's talk about what is the exact solution. Exact solution means no calculator. Exact solution means no calculator. Algebraically means showing all the steps. Show all the steps. That's what exact solutions means. No calculator. Algebraically means showing all the work. So first of all, let's take a look at this. 3 to the x plus 4 and 243. 243 we can rewrite as a base 3 is 3 to the 5. So this is 3 to the x plus 4 and 3 to the 5. We can drop the base. X plus 4 is equal to 5, and we can say x is equal to 1. Here, try to look for the smallest base. The smallest base is a 2. So I rewrite this 2 to the negative 1. 8 is 2 to the 3rd. Negative x is equal to 3. X is equal to negative 3. Some are very easy one. Think about this. What's the connection between 27 has to do with a 3 and 64 has to do with a 4. So 3/4 to the x. We are rewriting this as 3 to the 3rd and 4 to the third, which is same as 3/4 to the third, and I can say x is equal to 3. These are my answers. So take a minute and look what we have done. You do not need a calculator. You don't even have access to the calculator. Exact solution means answer without calculator. Algebraically means showing all the steps. So now let's take a look at the log equations. Log of 5x minus 1 over log 29 is equal to 1. So we can do the cross multiplication here. Log 5x minus 1 is equal to log 29. They both have a same base, so I can drop the logs and I can say 5x is equal to 30, x is equal to 6. Now anytime you are looking, whenever you solve the log equations, you have to check for extraneous. Extraneous means, is this a valid answer? Is a 6 good guy? Yes, log of a negative number is not defined, so you always check is substitute and you can check that 6 is good. So let's take a look at one more here. You can add the other side. You can drop the logs. 2x minus 4 is equal to 8. 2x is equal to 12. X equal to 6. I'm not completing this one, but I'm giving you the answer for this. The same strategy. Oh no, sorry. Let's do this problem. It's not the same strategy because we have a 2 there. So log is x plus 2 divided by 9x is equal to 2. This is very good example. Please pay attention to this question here. Properties of log, log minus log we rewrite. Now change to exponential. So change to exponential makes it 2 to the second is equal to x plus 2 over 9x. 2 to the second is a 4, so and you cross multiply. So 36x is equal to x plus 2, subtract x. X is equal to 2 divided by 35. How do I know my answer is good guy? This is a positive number. Positive number, log of positive number is always defined, so we don't have to worry about positive answer here in this case. Okay, we are going to look at, let's cross out number 7. We are not doing that. Let's take a look at this one. This is, you can change the base, but it would be much easier if you do the cross multiplication. They both have a same base, so I can drop the base. 625 is 5 to the 5 times 5, 25, 25 times 25, so this will be 5 to the 4th. And now we drop the base, drop the log. Now we here drop the base, and we can say x minus 2 is equal to 4, which gives me x is equal to 6. Okay, on this page, last but not least, this is a very important question. You have to know how to solve this. 8 over 1 plus e to the x is equal to 5. So I'm just going to explain here. If I have a over b is equal to c, I can also say a over c is equal to b, because these two are interchangeable. So this properties is going to help you for this problem. I can say 8 over 5 is equal to 1 plus e to the negative x. Swap the place of these two properties of fractions. A over b is equal to c. We can also say a over c is equal to b. So 8 divided by 5 is 1 plus e to the x. This is very easy way to solve the equation. Now all we have to do is subtract 1. Do not touch the calculator until last point. 8/5 minus 1 is 3/5. Now we have to take ln on both sides. Because we have a base e, so take ln on both sides. Ln of e to the negative x, I get negative x. And this side is ln 3/5. Yes, you could punch in the calculator, but we don't want to use the calculator, trying to avoid the calculator all the way until end. And now all you have to do is divide by -1. So I can say x is equal to negative ln 3/5. Now, if you have learned the properties of log, this is also same as ln 5/3, because the negative sign goes up and that makes it reciprocal. So I have this question, I have both solutions. You can write negative ln 3/5 or you can write ln of 5/3. They both are valid answer. In fact, you could use the calculator now at this step. Yes, you can use the calculator at the last step, but this is perfectly okay. You don't really need to punch in the button on the calculator. Just stop here. Okay, if you think this is going a little too fast, you can always rewind the video and watch it again, or you can pause and do the problem all by yourself and then play it again and check your answer. Now on the other side, we are going to do it a little bit more complicated problem. You cannot try to get the same base until you take care of this. So always think about using PEMDAS backward. I do not have any addition subtraction, so I have to take care of multiplication division, which is divide by 20. Direction is still same on this side. Find the exact solution. Find exact solution. Means no calculator. You are not using calculator at all. Show all the steps. Okay, so what 1/2 has to do with 1/4? 1/4 I can write it as a 1/2 square. And this side is 1/2 to the x over 3. Now you can drop the base and I can say x over 3 is equal to 2, which means x equal to 6. The rubric is you have to show step by step what you are doing. Use mathematics to justify. Do not do the math in your head. Show all the steps. Okay, so let's take a look at one more here with the same base. 36. What 36 has to do with the 6? So 36, I can write 6 to the second power. Then I cannot compare the base until I take it up as a 6. So I can write 6 to the -2 and x plus 2. 6 to the x minus 9. Now you can drop the base, and power of power is multiplication. -2 x plus 2 is equal to x minus 9. And this is a simple algebra part here. Distribute, solve for x, combine like terms. -2x minus 4, x minus 9. Don't forget to distribute the negative sign. This makes it -3x is equal to -5. I add 4 on both sides. Subtract x on both sides. So x is equal to 5/3. Exponential functions always have a domain all real number, so we do not have to check for extraneous. Exponential function, exponential equations, domain is all real number. There is no extraneous solution. But log equations, you always check for extraneous. So let's take a look at these two examples, which are very important one, and that's the reason I'm doing at the end. The 1 through 11 were considered category 3 or 4, but this is category 5. I'm going to do this problem 3 different ways, and we will see which method is a correct method. So the first equation is, some students love to bring 2 here as a coefficient. So then I get log x is equal to 1, and then log, there is nothing written, means the base 10. So 10 to the 1 is equal to x, x is equal to 10. This is method number 1. We are going to check which method is accurate. Okay. Some student says log of x square is equal to 2. Can I change the base right now to change to the exponential? This is a 10. So 10 to the second is equal to x square, which means x square is equal to 100 and x is equal to plus and minus 10. Well, the last method is graphing method. Using calculator, you can graph this log of x square and 2. You will see that this graph is going into the both direction, and x is equal to 2, it crosses twice. So which method is correct? These are the correct method. This is incorrect method. Incorrect solution. Why? Why this is incorrect? This is not correct method. You are losing a solution. There are 2 solutions, 10 and negative 10, 10 and negative 10. Now, how do we know that the negative 10 is not extraneous? So let's check in here. Put x is equal to negative 10. Checking part. Log negative 10 square is 2, which is true because negative number square becomes positive. So what's happening here is, when we change the exponent, which is an even number, and we bring it as a coefficient, we are messing around with the domain. We are manipulating the domain. That's the reason when you are solving equations, do not bring the exponent as a coefficient, because there is a domain error, which is rarely you are going to see this. Rarely you are going to see this. But I just wanted to make sure that you understand that there are 3 different ways to do this problem, and these 2 are correct, but you bring the exponent as a coefficient and the domain is changed, and that's why you have missing answer. Okay, so the last but not the least on this page, I'm saving the best one for the last. Okay, so a lot of things are involved here, so make sure you pay extra attention here. So first thing is, I'm using my properties. So ln x plus ln y. You know what to do here. Multiply. So let's rewrite ln 3x minus 2, x minus 1. See the previous example is different. Here we have to bring this 2 up here. We are moving as an exponent, not bringing down the exponent. So I would bring 2 to the x. Okay, so FOIL. I'm just writing all the hints on the side. Many students are struggling with the foiling part. So I'm just writing that. I'm bringing my answer here. 3x square negative 3x minus 2x, which is minus 5x, plus 2 is equal to ln x square. Drop the logs. 3x square minus 5x plus 2 is equal to x square. Subtract x square. And now factor. So this question is testing all the math skills you have learned before. I prefer my guess and check method because 90% of the time you are going to see the leading coefficient 2x and x. So I'm writing 2x squared minus 5x plus 2 factor. Some students prefer to draw the box, some students, whichever way, I'm not teaching you how to factor. I'm just moving on to here. My answer is so then 2x minus 1 equal to 0, x minus 2 equal to 0. X is equal to 1/2 and 2. Okay, so let's checking part. This says check for extraneous. Check. If I put x is equal to 1/2, what's happening here? Ln of 3/2 minus 2 plus ln of 1/2 minus 1 to ln 1/2. And if I check this term here, 1/2 minus 1 is negative half. Log of negative number is not defined. I call them party pooper. So which means this is my extraneous solution. This is my extraneous solution. There is only one answer. X is equal to 2. You have already learned what is the extraneous in a rational function unit. What is the extraneous means when the solution you substitute in the original one and the original one becomes undefined. In other words, party pooper. That means that's my bad solution. Now notice that 1/2 is a positive answer, but still it is a bad one because 1/2 minus 1 becomes negative half and log of negative number is not defined. Now let's check x equal to 2. Well, you can clearly see ln of 3 times 2, 6 minus 2, which is good, plus ln of 2 minus 1, which is good. Ln 1 is a 0. And 2 ln 2, which is also good. So yes, this is my good solution. That's a bad solution. So now let's talk about how this problem would be graded. What will be the rubric? So I'm going to explain the rubric for this problem because you must understand where the grade will be. If you mess up anywhere, that means you are not going to get the final answer. So the first thing we are checking is, are you applying properties of log, which is this one. The next point is, can you multiply together? One point here, which is you are foiling. The third point is, can you, dropping the logs, everybody can do it, but solving this equation. So of this here, this piece is one more point that you are factoring. You know how to factor. The last piece is one more point for checking for extraneous. So this question would be, and the final point for the solution. So this is roughly 5 points question, which is worthwhile. Make sure you know how to do it as we are using every single properties. For practice, we have a homework here. Make sure exact solution means no calculator. Copy the problem clearly. 1 through 10 is getting the same base. Some are very easy questions, some are slightly complicated. You can see that how easy this is. X is equal to 10 to the 4. That's so easy. You don't even need to do any work. You don't have to show any work here. Then these are the log equations. Make sure you know how to do it. Follow PEMDAS. All these are follow PEMDAS. Backward. And the last is very similar to what we did here. We did this kind of questions too. So try your best. Answers are posted in the textbook solution folder. You can check your answer, and this homework is due on Wednesday. Okay, I'm going to stop here. Hope everybody had a great winter break. I will see you on Wednesday during virtual check-in. Thank you.